Assignment 2, Part 4. Today we're going to look at some absolute value questions. Okay, so the first section is solving an absolute value inequality problem type 3. In these problems, they want you to graph the solution. So the way we solve inequalities, we're going to absolute values. We're going to isolate the absolute value. I'm just going to put like an x plus 2. 2, we're going to make 2 equations. And then 3, we're going to solve each equation. And another hint is a greater than problem will be or, a less than problem will be and. So let's take a look at the first problem, and I'll explain these steps. It's greater than. This is going to be an or problem for graphing. So we're going to take everything. This one's a less than. Eventually, this will be an and problem. So let's just start with number 1. So our absolute value is already isolated. There's nothing plus or minus. There's nothing multiplying. We will see that soon. So we're going to make 2 equations, and here's how I do this. My first equation, I drop the absolute value. Keep wanting to say inequality. Okay. And then for the second equation, we're going to take that u plus 7 in here. We're going to make that 3 opposite. We're going to make it a negative 3. And because really what we're doing is multiplying by negative 1, we have to remember to flip this inequality. So big step right there. You got to flip that. Okay. So we already from here to here, we already flipped it. Okay. Now just solve both for u. Subtract 7. U is greater than negative 4, or subtract 7. U is less than negative 10. So on a number line, we're looking at negative 4 and negative 10. They'll give you a complete number line. Greater than negative 4, so bigger than negative 4, open, because there's no bar. Less than negative 10, open, going that way. So we're taking everything. Both pieces are the answer for graphing because of the or. And we knew this was or because the greater than sign gives us an or problem. Now, less than is an and problem. So we're going to make our 2 equations. Now, the second one, remember, we change the sign on the right to the opposite, so it'll be negative, and we have to flip the inequality. So if we add 4 less than 8, if we add 4, it's greater than 0. So smaller than 8, bigger than 0. It's the and, so you only take what's in common. We did this last video. I'm just going to jump to the answer, and there you go, 0 to 8. That's how you would graph that solution. Okay. And how do we know that? The greater than will be or. If it's greater than or equal to, it's still or. Less than or equal to will be and. Okay, next topic, solving an absolute value inequality problem type 5. There's no graphing here. You just have to write down the answer. So we're going to follow those same rules, and we have to do the extra piece. So the first thing you want to ask yourself is, I want to isolate my absolute value of 3 to the u. So I want to get that all alone. So how do I get rid of this plus 22? I subtract 22 from both sides. So absolute value of 3u. Draw those big so they don't look like ones. That's my recommendation. Is greater than or equal to 2. So already I know this. This is going to be an OR problem, and I'll show you. We're going to put OR in our answer. So now you make your two equations. 3u is greater than or equal to 2. 3u, we flip the inequality and change this to the opposite, so negative 2. So divide by 3, u is greater than or equal to 2/3, or u is less than or equal to negative 2/3. And this is an easier problem. These won't always be exact opposites. It just happens here. So this is what would go in Alex. No graphing here. Okay, let's look at another problem. Number 2. All right, this is an and problem. So Alex, we're not going to use and in our answer. I'll show you when we get there how we have to answer this. So first step, isolate the absolute value. So we're going to subtract 6 from both sides. So we get the absolute value of 4v minus 2 is less than or equal to 14. Now make your two equations, always two equations. 4v minus 2 is less than or equal to 14. 4v minus 2 is greater than or equal to negative 14. So add 2 to both sides. Divide by 4. Okay, add 2 to both sides. Oop, did I? Good, I flipped that, good. Add 2 to both sides. Divide by 4. X is greater than or equal to negative 3. Okay. So we're greater than or equal to negative 3, less than or equal to 4. Alex, I was looking at the Alex answers. They write this as like a compound inequality. They might take the word and because when you when you insert your answers, there is an and option. But the way they wrote it as an answer, they took the smaller number is less than or equal to W. See how this, V, my fault. See how this opens to V, how it still opens to V, is less than or equal to 4. This is the same thing as greater than or equal to negative 3, less than or equal to 4, negative 3 to 4. Just write it in order and use less than symbols. And this is the and problem when we start with the less than or equal to. That tells us and. Okay. Maybe Alex will accept this and this. I'm not sure. When I look at the answer, this is what it shows me. Okay. Number 3. If you would like to try this problem, pause it. I'm going to go through the problem now. Actually, this is a special case, so let's go through it. Okay, so I'm going to subtract 7 from both sides. I'm going to divide by 5. Okay, I'm going to save you a lot of work here. Whenever you isolate an absolute value, So after isolating an absolute value, if you get a negative number, it automatically tells us you can't take you can't take an absolute value and be smaller than a negative number because the absolute value is always positive. I mean, it could be zero, but it's always zero or positive. Is zero or any positive number going to be less than or equal to negative 25? No, impossible. So if you get it, once you isolate, you can't look here because sometimes when you, if this was a -5, this would turn positive and it would work. But once you isolate, if you get a negative number over here, you can automatically tell Alex and me that it is no solution. So if you notice that, you'll save yourself a lot of time. Oops, and I did make a mistake. Sorry. Negative, I was jumping ahead. Negative 25 divided by 5, we should get -5. My fault. Okay, so negative 25 divided by 5, we should get -5. I made a mistake there. So it's still a negative number, no solution. Okay, so we're done. That's an easy problem. Quick. Okay, now if you want to pause this one, go for it. Try it. Unpause the video. I'm going to do the problem out right now. So I'm going to subtract 5 from both sides. So 6v plus 6 is greater than 18. So remember, this is going to be an OR. So we write 6v plus 6 is greater than 18, or 6v plus 6 is less than -18. And just solve. 6v is greater than, subtract 6, 12. V is greater than 2. Subtract 6. 6v is less than -24. Divide by a positive 6. So we're not flipping anything. -4. So and this is just an OR. So we're less than -4 or greater than 2. And that's your answer. Last one. Add 9. 5. V plus 7 is greater than. 11 and 9 is 20. Okay, we have to get the absolute value all alone, so divide by 5. I won't forget that this time. Divide by 5, cancels. V plus 7 is less than 4. Now make your two equations. V plus 7 is greater than 4. Remember, this is going to be an OR here. Or V plus 7 is less than -4. So subtract 7. 4 minus 7, -3. V greater than -3. Or subtract 7. V is less than -11. Greater than -3, less than -11 there. And that completes this part of our lesson.